Hey guys, what's up? My name is Gabe, and this is Games with Gabe, and today is the next episode of the Game Engine Concepts tutorial series. So, what we're going to be talking about in this particular episode is something called the command pattern, and I have in subtext, implementing undo and redo. So this pattern can be used to implement an undo-redo system or some other cool things that we will discuss in a minute. Now, before we do begin talking about this, some of you might not know what a pattern is, and that's fine. When I first figured out about patterns, I was like, this is cool, but I don't see a use for it. Now I'm actually using them because they are very useful. So what a pattern is, it's something called programming pattern specifically. It's something that supersedes any programming language, and it's a concept that ends up finding its way into your programs very often. And so some programmers in the late 90s, I believe, called the Gang of Four, decided to create a book called Programming Patterns or something like that. And basically they defined some basic programming patterns, things like singletons, strategy, and all sorts of other stuff. And then later on, I think probably a few years ago, Bob Nystrom wrote a book called Game Programming Patterns, in which he sort of went through the classic Gang of Four patterns, but then he added their context in a gaming scenario, and he added some other patterns that lend themselves to gaming. These are very helpful because they're common problems that programmers over the years have run into, and they figured out, hey, if you use this pattern of programming, it ends up solving the problem in the least amount of effort. And so that's what we're going to be talking about today. So what is the command pattern? The command pattern is actually a pretty simple concept with some profound results. So what you have is typically, if you're in a object-oriented programming language, you have some class, we'll call it iCommand, which is an interface. And so this interface has one function, sometimes more, which we'll look at in a minute, called execute. And what happens is when you call execute, it executes a command, okay? So some examples of commands might be something like a move player command. This is kind of easy to understand. So basically what happens is when you create the move player command, you pass in some vector, some vec2 possibly, or vec3, that you want the player to move to when you make the command, and then you call execute when you want to execute the command, and what happens is the player moves to that point. And you may be saying to yourself, what's the point of doing this? You could literally just say, let's just set the player's position to whatever we were going to set it to in the first place. But we'll take a look at why this is important in a minute. Then you could abstract this even further, which I have done because I realized there's no point in having these specific things. You could just have something called the change vector command. And this way it's applicable to all objects regardless of class. It just operates on data. And so then you have this sort of data-oriented command pattern, and you can literally use this for every single modification of data. And what ends up happening is now literally everything you do is undoable and redoable just because of this pattern. How does it become undoable and redoable? The best way to visualize the command pattern in action, I think, is through the use of another wrapper class around this. I made a class called command history. And what command history is it's just a list of commands, as you can see. So you've just got an array of command, and you have a current pointer. This could be an index, so this could also just be the index, current index, or current pointer to whatever command you're currently pointing at. I hope you can begin to see how we can use this to undo and redo things, because now, if we've kept track of every single command and we've wired it all through, instead of doing like changing the player's property directly, instead we wired it through a move player command. Now all of a sudden that move player command, we moved it 1, 2, 3, 4, 5, 6 times, and maybe we did a couple other commands in between there too. If we want to undo what we just did, all we have to do is go back to this command, right? How does that work exactly though? Well, you just add one more function to your interface, undo, okay? And this still might not make sense as to how this will undo the command. And the way it works is basically, say you had a change vector command, okay? So we have some change vector command, and say the constructor of this command looks something like this, change, and it takes in a vector 3, and we'll say this is the new vector. And then another vector 3, and we'll say this is the vector to change, okay? Now what we do is we would implement this execute function, right? First of all, we would have to implement that. So what could we do? We could say, okay, on execute, what we'll do is we will just say the vector to change dot set to the new vector. And so what does this do? Well, depending on your exact implementation of vector, what this would do is it would basically just set all the values in the new vector and set them to the vector to change. So basically, this is a reference to the actual vector object. So say this was the player's position, player.position. You would pass in a reference to the actual object. And then basically what happens is when you set it inside this execute command, you're actually changing whatever vector you passed in. Now, this doesn't solve our undoable problem though, right? We can't really undo right now. And so what we can do to implement that undo functionality is we'll just give ourselves a little bit more space. And what we'll do is we'll have a private member variable inside of this change vector command, right? And we will say, okay, this is the vec3, the new vec, and then we'll say vec3, the old vec, and then vec3, the vector to change, of course, because we have to store that as well. Then what we do is we store in the constructor, we store the new vector. We just put this new vector into here. We put the vector to change into the vector to change. We just set those equal, literally. But then we copy the data inside the vector to change into this old vector object. Or even better, what we do is when we execute the command, we say old vec dot set vector to change. So what happens now is right before we change the vector that we're trying to change, right before we change the player's position, we set the old vector to all of the player's data, right? Then we change the vector we actually want to change. Now, what does that do for us? It means now we have this command inside of this list, right? Because say we added it to our command history. Now, this command has the old position that the player was at. It also has the player's actual position object. Now, implementing undo is actually pretty easy, right? Because what do? Undo would look something like this. If we want to undo, all we would have to do is say, okay, vec to change dot set old vec. That's literally it, okay? How does this work? So basically, say you have this command history object, right? And what you would do is you would basically have a function in here that's also called undo. And so this is like your master undo. He does not care about any implementation details. All he does is calls this abstract, this virtual method undo on the current command you're pointing at. Now say we created a new command, right? We wanted to change the vec command, and this was pointing to the player's position. So we basically set the old vector inside of this object, which is now stored inside here, right? This is the actual command. We store the old vector to whatever the player's vector was then we say vec to change.set new vector, so then we actually change the player's position. But you're like, uh-oh, that was the wrong move. I actually want to undo that. Well, that's actually really easy to do now because we have this undo method. So we know we're pointing at this command, which we just placed into this list, right? And so we'll just say, okay, command, we just say cmd dot undo. And then we just decrement the current index so that now current index is pointing at this command, right? Because now we just undid this. This is amazing, guys, okay? So literally just by doing this one simple wrapper class, which has an interface, which has an undo command, we can undo these changes very easily. Wait, how would you redo though? There's no redo function inside of this I command. So how in the world are you supposed to go back? And that's the beauty of this pattern. Look at it. We already have the do command. It's just execute. So if then you wanted to say, oh no, I want to redo, you would call redo on command history, right? Then what happens is he just calls this command's execute. Well, what does that command's execute do? It would bring us right back to the state we were just at. And so literally if we just execute the execute command on this command right here, we'll just go back to the state we were at. And then say we had actually undid some stuff before that too, and we had more commands lined up in front. If we wanted to keep redoing, all we would do is say, okay, execute again, and now all of a sudden we're at this state. Now say we make some more mistakes and we want to go back, well, that's easy. You just undo, 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 and you can keep undoing until you hit the beginning of the array, and you can keep redoing until you hit the end of the array. Now, the only complication in this is what happens when you insert a new command. So say you're pointing right here, and so you were pointing here just a second ago, but then you undid a bunch of commands, right? So now you're pointing here, and then you create a new command. So now you're like, okay, I did something different than what this guy was. So it's simple. All you do is you create the new command, place them in there, move the pointer forwards, and then you basically just delete everything after it and say, okay, now the new end of the list is right here. That way you don't end up with weird cases where you redo up to here and then you keep redoing into commands that technically aren't available anymore. They're just ghosts. So to stay away from the ghost, we just make sure to delete everything that is dead and put them in their graves where they belong. I hope this is beginning to make sense a little bit. I will have a link to a great article by Bob Nystrom, and it's like the actual article that he wrote. It's a chapter in his book about the command pattern. There is one more thing that I want to talk about, though, that he does not talk about in his article, and that's merging. So I included this last command pattern or this function inside of the command interface because I was running into a problem. Say you're using this just as I was talking about, but you're not playing a game like chess where basically if you move your pawn from here to here, it's an instantaneous move, right? What if you're playing some top-down RPG where you have a player and that player is moving based on some controller input, right? So the player holds down up for 5 seconds. What that is going to do is it's going to issue like 1,000 of the change vector commands, right? It's going to be like, okay, he's pressing up, and then the next frame, he's pressing up, next frame, pressing up. So every single frame, you're going to get a command. So one command per frame. Now, this can be a problem because, first of all, you'll be creating a bunch of these commands. So you may have memory issues, especially if they're larger commands. But more importantly, if you wanted to undo, you would have to hit Control-Z and hold Control-Z for 5 seconds so that it simulates, oh, okay, we're moving all the way back here, and then we're here. Instead, what I'd like to do is say, while the user is pressing up, we'll act like this is the first point, right? But then say the user releases up arrow when he gets to here. Then this is where we want the command to end. So we say like command N, and then if they say undo, then we would want to undo all of those previous points because they probably meant to undo that whole action, right? We can consider the holding up as an action. And so what I did to implement this is I added one more function called merge with I command. So it takes in another command and it's this property merge with. Basically what this does is say you have your command list in here and then it will check and see if the command behind it is of the same type. So say this was move player, right? So this was technically a move player command, and this one was also a move player command. So we know they're the same command, so they can be merged together. So that's the first step. And then once we realize that they can be merged together, all we do is we say, okay, just set this guy's vector to change to whatever this guy's new vector was, right? So we'll just say, okay, so plug in this new vector into this command, and then we can literally just move it back again and then pretend like this command was never issued. And then that way what we get is every single frame we get a command added, right? But then we're like, oh, we can merge this with the one behind us, erase that, go back to the one behind us, then we add another command, we go back and we add it to the one behind us. I think this will be easier to see with a concrete code example, so we will check out my code so you can see an actual example of how this would work. All right, so we will very briefly take a look at 3 files to explore exactly how the command pattern works one more time. So this is the iCommand class, all right? And what you need to focus on, if you're not familiar with C++, that's fine. These are just like abstract functions would be in Java, or virtual is the equivalent in C++. So what you see is I have this virtual void or this abstract execute command. Then I have an abstract undo command, and then I have an abstract merge with command, which also returns a bool to let me know if it did successfully merge or not. Now we can sort of ignore these details. These are just a little bit more extra information that I use. But these are the important things. We have the constructor or a virtual destructor. We have an execute and an undo command, which are both abstract. Now, when we implement this, say we implement it in a change vector 3 command, and we want to implement this I command. What we do is inside we create a custom constructor that takes in the original vector and the new vector. And then we just initialize everything. We say, okay, so we have some properties. We have the vector, that is the one that we're using to change. We have the new vector, and then we have the old vector. So we just initialize them here. We say, okay, we'll put the vector as whatever the original vector was. then we'll set the new vector as the vector that we want to change it to, and then we set the old vector to some random data. Then when we execute, we do exactly what I said. We set the old vector to whatever this would be, like player's position. So you can think of m vector as if it was the player's position. Then we basically set the player's position to the new vector. And then to undo, we just set the player's position here back to the old vector, which we set right here. So undo and redo are pretty simple. Or undo and execute are pretty simple. Now the merge with command is a little bit more complicated, but it's still not that bad. Basically what we do is we say, okay, let's try and cast the command that they're sending in that they want us to merge with. We'll try and cast it to a change vector 3 command. And then we basically check and see if that cast succeeded. If the cast did succeed, first we check and see if they're operating on the same vector. So if these are both operating on like the player's vector, this would check and see if like his vector equals my vector. And if they are indeed the same object, then I know that I can actually merge these. And then I basically just say, okay, set the other guy's vector to the other guy's new vector to my vector. And it sort of implements that merging. You might want to stare at this one for a little bit more because it is a little bit more complicated. And then the last big piece is the command history. And so what I did was I basically just created this custom array of commands. So it holds up to 1,000 commands. And I just store two variables, the command size and the command pointer or the command index. And then I have this function add command. And so basically every time you create a command, you just add it here and then you call execute on the command. So say I wanted to move the player, I could call command history add command, and I would say new change vec3 command player dot position to, and then like whatever vector I wanted. So I could say like if we were in Java, new vec3 111. Okay, and then basically what happens is just by saying add the command, it creates the command inside the inside of this function call, and then it executes it right here. So we don't even have to worry about executing it. And then basically what I do is I just check and see if there are any commands in front of it. So say you had command, 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 and we were currently pointing at this guy, then I would go ahead and delete this command since he's going to be getting rid of, sort of. So I delete all those, and then we go ahead and we actually insert the command into our array. So that's where we do this. We say, okay, we just got a new command, and then we check and see if they wanted the command, if the commands can merge, and if they can merge, we try and merge the two commands together. And then if they successfully merge, we just decrease the size again and we delete the new one. And then we set the pointer appropriately. This is a lot, I know, but basically what's happening is we're just sort of merging it if we can and executing the command that they just asked us to add to our command history. Then I have this helper function too that says set no merge most recent, and basically what this says is it basically says I want to stop merging all commands, and so this will make sure that we can't merge any more commands. And then undo simply calls undo on whatever the command pointer is pointing at, and we decrement the size. And redo, all that does is it increments the command pointer, and then we call execute on the current command. So undo and redo are actually pretty simple. It's the merging that gets a little bit more difficult, and adding the command can be difficult. But this is a concrete example. Take a look at the code for a little bit longer if you want to. I'll have links in the description so that you can actually see the source code for yourself too. I'm also going to mention just in passing that one of the last things that you can use this for is, you know how in racing games like Mario Kart or Forza Horizon, first of all, Forza Horizon has that replay technique. I'm guessing they use the command pattern for that. Also, how Mario Kart continues to play the race afterwards, and it has the instant replays, right? How do you get an instant replay? It's easy. You just create the command pattern. You store up the commands that the player's executing. Then when you find the instant replay that you want to do, you would just say, okay, just undo to where we want to start instant replay. Then you would say, okay, now execute until we get back to current time. Okay? It's really that simple. We just execute a few undo commands. It looks like the game's playing in reverse. Then we say now re-execute those commands until we get back to wherever we were. And if you store the whole command for the entire game session, This makes debugging easier because say you're creating your game and some bug goes wrong an hour into your gameplay session testing your game. How in the world are you going to figure out what that bug was, what caused it? Well, if you log out a report of every command, every single command, then you can create some sort of program that literally just goes through and executes every single one of these commands, and then you can figure out which command your game went wrong on. So the command pattern is not only for undo redo, it's also for debugging, and it is also for cool features such as instant replays and for wiring AI input and everything. So it's a very versatile pattern, and I really hope you guys start using it because it can be very useful. Now, I didn't talk about implementing this in functional programming language. If you want to take a look at that, take a look at Bob Nystrom's article. He has a cool little demonstration of that at the bottom of that article. That is it for this tutorial, though, guys. If you liked it, please hit like and subscribe, and I'll see you in the next one. Thanks.